Welcome back to Testing Guru. So in last video, we have learnt what is testing, what is the software testing and what's its definition, why software testing is important, what is the need of testing and what is the benefits of testing. So I will give the link in the description for the last video if you have not gone through. And today we will be learning types of testing and 7 software testing principles. We'll learn with examples and we'll learn about V model in software testing, and also we'll learn about STLC, the software testing lifecycle phases and entry and exit criteria. So first we will look into what are the different types of testing. So coming to testing, we have mainly 3 types of testing we do. That is a functional testing, and second one is non-functional testing, and other one is a regression testing. So under functional testing, we do a different kinds of testing that is also called as white box testing, black box testing, user acceptance testing, UI testing, API testing, database testing, system testing, integration testing, sanity, smoke, as well as unit testings. So we'll learn more about like each testing, what exactly it means in coming session. But this is the main areas where we do a functional testing. And coming to the non-functional testing, this is also called as performance testing. And not only a performance testing, it has other testing also in the non-functional area. We do a performance, along with that we do a load testing, stress testing, scalability, and usability testing as well. And the third part is the regression testing. This is the extension of functional testing, where we do regression testing, and mainly like nowadays the regression testings are executed with automation script, because those are the superset of the test cases where we have to run at each and every build whenever there is a release. So initially like people used to do a manual testing, but those regression suits are now they are getting added in the regression suite. So that's how the automation testing comes into picture. So we'll learn more about all those testing, so as we go with the basic. So next chapter is about the 7 software testing principles. Okay, so coming to 7 software testing principles, uh, why it is required and all, we'll just see. It is important that you achieve a optimal test results while conducting a software testing without deviating from the goal. But how you determine that you are following the right strategy for the testing? For that, you need to stick to some basic testing principles. Here are the common 7 testing principles that are widely practiced in the software industry. To understand this, consider his scenario where you are moving a file from one folder to another folder. Okay, think all the possible ways you can test this feature. Apart from this, using just moving the file from one folder to another folder, you can think of the below these scenarios, like trying to move the files from when file is open, uh, then you don't have enough security or a permission to paste into the another folder, the destination folder. And also like the folder where you are going to move that file is shared drive and storage capacity is full. In that case, what will happen? So those scenarios like we need to think. And along with that, like we already have a file existing in that particular target folder. When you try to move that, what message you get it? Okay, so there are multiple test scenarios you can build like this. Also, like if you are supposed to have 15 input fields in the test, and each having a 5 possible values, the number of combinations tested will be 5 into 15. So if you are testing the entire possible combination for the project, the execution time and the cost would rise exponentially. we need to certainly, we need to certainly use some principles and strategy to optimize our testing effort. And here are the 7 principles. First one is exhaustive testing is not possible. Okay. Yes, exhaustive testing is not possible. Instead, we need to optimize the amount of testing based on the risk assessment of the application. And the $1,000,000 question is, how do you determine the risk? To the answer to this, we do an exercise. If your opinion, which operation is most likely to cause your operation system to fail. So based on that, you can identify the risk. I'm sure most of you would have guessed opening 10 different application all at the same time would be the ideal risk. So you were testing an operating system, you would realize that defects are likely to be found in multitasking activities, and you need to be tested thoroughly, which brings us to our next principle, that is on the defect clustering. So defect clustering is which states that small number of modules contains most of the defects. This is the application of the Pareto principle of software testing. Approximately 80% of problems are found in 20% of the module. By experience, you can identify such risky modules, but this approach has its own problems. If the same tests are repeated over and again, eventually the same test will no longer find the new bugs. So for that, we have to adopt another principle. So next principle is the pesticide paradox. Pesticide paradox is like repetitive use of the same pesticide mixed to eradicate the insects during the farming will over time lead to the insects developing a resistance to the pesticide, thereby ineffective of pesticide on the insects. The same application applies to the software testing. If the same tests are repeatedly tested, against the product, and the methods will be useless for discovering the new defects. To overcome this, test case needs to be regularly reviewed and revised. Additionally, new different test case can help to find more defects. Testers cannot simply depend on existing testing techniques. He must look out for the continuous to improve the existing methods to make testing more effective. But even after this sweet and hard work is in testing, you can never claim that your product is bug free. To drive home this point, let's see how Windows 98 launches. Okay, you think a company like Microsoft would not have tested their OS thoroughly and would risk their reputation just to see their OS crashing during the public launch. So next principle is testing shows a presence of defects. So that's one of the principle. Hence, testing principle states that testing talks about the presence of defects and don't talk about the absence of defect. That is, the software testing reduces the probability of undiscovering the defect remaining in the product. But even if no defects are found, it is not a proof of correction. If it is not a proof of correctness. But what if work extra hard, talk to all precautions, and make your software product 99% of bug free, and the software doesn't meet the needs and the requirements of the client? This leads us to the next principle, which states that absence of error. Absence of errors fallacy is possible that software which has 90% bug free is still unusable. This can be a case if the system is tested thoroughly for the wrong requirement. Software testing is not mere to finding defects, but also to check that software addresses the business needs. The absence of error is fallacy, that is, finding and fixing defect doesn't help the system to build unusable and doesn't fulfill the user needs or the requirement. To solve this problem, the next principle of testing, that is called early testing. Early testing should start early as possible the software development lifecycle starts. so that any defects in the requirement or the design phase are captured in early stages. It is much cheaper to fix the defects in the early stages of testing, but how how early and one should start testing? It is recommended that you start the finding the bugs at the moment of the requirements are defined. More on the principles in the later we'll learn. Okay, testing is a context dependent. So what does this mean? Testing is a context dependent, which basically means that the way you test the application will be different from the way you test, like for example, e-commerce application with a commercial application. Okay, all the development softwares are not identical. So you might have to use a different approach, methodologies, techniques, and types of testing depending on the application type. For instance, testing a POS system. As I told in the last video, POS is a point of sale system. At the retail store will be different than the testing a ATM machine. So my is like principles are just reference. I will not use them for practice. This is not very untrue. The testing principle will help you to create an effective test strategy and draft error catching test cases. But learning testing principle is just like learning to drive for the first time. Initially, while you learn to drive, you pay attention to each and everything like gear shift, speed, clutch, handling, etc. But with experience, you just focus on driving the rest, and rest all comes naturally, such that you even hold conversation with the other passengers in the car, so it doesn't matter. Same is true for here in the testing principles. So experience of the testers matters. Okay, so now we'll move on to the next topic, which is a V model in software testing. The V model is a type of SDLC model where the process execute in a sequential manner in a V shape. It is also known as verification validation model. What is meant by verification? Verification is it involves a static analysis of techniques, that is called reviews, done without executing the code. It is a process of evaluation of the product development phase to find whether the specified requirements are met. And validation is involved dynamic analysis technique like functional, non-functional testing done by executing the code, and validating is the process of evaluating the software after the completing the development phase to determine whether software meets the customer expectation or the requirement. So here the development and the testing will go in hand. Like whenever there is a requirement analysis is done from the development side, acceptance testing criteria will be designed from the testing side. Same like when the system design is done by development, system testing starts from the QA side. And the same like when the coding is done, the unit testing is done, like after that like QA will start integration testing, acceptance testing, and then it goes to the prod. So this is all about the V model of software testing. And now we'll talk about the STLC. So STLC is the similar way where we use like how we use SDLC. So in SDLC we actually do a software development lifecycle, but STLC is a software test lifecycle. Okay, so there are 6 major phases of software test lifecycle. That is a requirement analysis phase, test planning phase, test case development, and test environment setup, test execution, and test cycle closure. So these are the different phases of the test lifecycle. How we have like this in the SDLC process, the same way we have for the STLC. And for STLC to start, to start testing, we should have an entry criteria and exit criteria. So what is the entry criteria? Entry criteria gives a prerequisite of items that must be completed before testing can begin. That is an entry criteria for the testing. And exit criteria is defines the items that must be completed before testing can be concluded. So this is all about today's video, and in next video we will learn about test case development. How do we document the documentation in the software testing? What is the test scenario? How to write test cases? And what is the test analysis? What's the requirement traceability matrix? And how do we generate a test data? And I will give a sample test case template. So don't forget to subscribe for the testing guru, so that you can get a notification of my next video. And thanks for watching.